What's up everyone, welcome back to the channel. Today we're breaking down network engineering for complete beginners, but in a way that actually makes sense. If you ever wondered how the internet really works, why routers and switches matter, or what all those layers of the OSI model even mean, this video is for you. By the end of this, you're going to understand the entire flow of how data moves from your phone all the way to the biggest data centers in the world, using simple analogies and real explanations. Let's get into it. The easiest way to understand networking is to picture the internet as a giant city. Your devices are the houses, your IP address is your home address, switches are the roads in your neighborhood, routers are the highways connecting city to city, and firewalls are your neighborhood security guards. Networking is basically making sure everyone gets to the right place safely and fast. That's really what engineers do. We make devices talk to each other reliably, securely, and efficiently. So, how does the internet actually work? At the core, the internet is nothing but signals, cables, packets, and data moving around constantly. Even wireless networks depend on wires. The world is connected by massive fiber optic cables running under the ocean. So the flow looks like this. Your device to your router or modem, which connects to your internet service provider, which then communicates with the nearby data centers, and which communicates with the global data centers, and then back to you. So behind the scenes, all these data centers are constantly talking to each other, forwarding traffic and keeping the internet alive 24/7. Network engineering is simply the art of making devices communicate reliably, fast, and securely. In human terms, this is what we do. We connect systems, we design how data travels, we troubleshoot when things break, we keep the network secure, and we make sure everything stays fast and stable. So if the internet is a giant city, network engineers are the city planners, road designers, traffic controllers, and security teams, all in one. Now let's look at the blueprint of communication, the OSI model. The OSI model breaks down communication into 7 different layers, from the physical wire all the way up to the apps we use every day. Layer 1 is cables and signals. Layer 2 is MAC addresses and switching. Layer 3 is IP addresses and routing. Layer 4 is TCP and UDP. Layer 5 builds the session. Layer 6 handles formatting and encryption. And layer 7 is the applications we interact with. We'll go deeper into each layer in the future videos, but for now we're just going to take a look at a high-level view. The OSI model is the blueprint that explains what happens every time you load a website, refresh an app, or even send a message. Now we have the TCP/IP model, which is more of the practical version. Now the OSI model is great for learning, but in the real world we actually use the TCP/IP model. It compresses everything into 4 layers: application, transport, internet, and network access. Think of it as the OSI model, but simplified and actually applied in real networks. Now let's break down each layer of the OSI model on a high level view. The physical layer is the pavement. If the cable is damaged, nothing else matters. The data link layer is your neighborhood. Frames and MAC addresses stay local. The network layer is the highway system. Routing and IP addresses take you anywhere in the world. The transport layer is your delivery service. TCP makes sure your package arrives safely, while UDP just sends it fast, like USPS. The session layer runs the conversation. It starts it, keeps it alive, and ends it. The presentation layer is the translator. It formats, encrypts, compresses, and makes data readable. And the application layer is the interface. The apps you touch, the websites you use, the services you interact with. Let's speak on some important concepts when it comes to the internet, like a LAN. A LAN is your home network, small, local, private. It usually uses Ethernet or Wi-Fi. A WAN is the big picture. It connects different LANs across cities, states, countries, and your ISP, corporate networks, cellular networks, satellites, all of that is WAN. Network topology is simply how everything is arranged. Star, mesh, ring, hybrid, each design solves problems like scalability, redundancy, and efficiency. Now let's bring it all together with the 3-tier network architecture. And this is where the analogy gets really good. Network architecture explains how data moves from the devices inside your home to the biggest systems that power the internet. The simplest way to understand it is to start with your home. Inside your house, you've got phones, consoles, TVs, smart speakers, computers, tablets. All of these are end devices. They sit at the edge of the network and rely on layers above them to communicate with the world. All of these devices connect through your home router. Even though it's marketed as a Wi-Fi router, it's actually switching traffic, providing wireless access, and acting as your first gateway out of the internet. This entire area, your home, and everything connected to it is the access layer. Now zoom out to your whole neighborhood. Each home is one access layer, and all of these access layers need a place to connect upward. This next step is the distribution layer. This is where traffic gets aggregated, policies get applied, and routing decisions get made. Every neighborhood in this analogy represents a distribution point. Now zoom out again to the city level. Multiple neighborhoods feed into something bigger, the core layer. This is where the high performance backbone equipment lives. The fast links, the data centers, the big routers that tie into entire regions together. The core is the spine of the network. When something breaks here, everything underneath is affected. Put it all together and the flow makes sense. Access to distribution to the core. The access layer is where the devices live. The distribution layer manages and directs traffic. The core connects everything to the rest of the world. This design is used everywhere, from your home network to enterprise networks, cloud providers, and global service providers. It's how your phone reaches Instagram, how companies connect to offices across states, and how the world moves data reliably and at scale. So that's networking for dummies, but actually explained in a way that makes sense. If you want deep dives into each OSI layer, routing, switching, Wi-Fi, subnetting, VLANs, and how real enterprise networks are built, make sure you're subscribed because I'm breaking each of those down in future videos. Drop a comment if there's a specific topic you want next and I'll cover it. Thanks for watching and I'll see you in the next video.